HVAC 360, episode number 9. My interview with Jim Wickert. Welcome back, everybody, to another edition of HVAC 360. I'm your host, Matt Nelson.
I want to thank you for joining me. We keep growing this every week and week in and week out, and that is absolutely fantastic. This week has been very special to me because I started doing one of the things that I set to do in the beginning when I did the prologue is talking with building professionals, in this case, a consulting engineer from Cleveland, Ohio, Jim Wickert. Now, Jim's been doing this for about 50 years, and he is really one of the icons in Cleveland as far as engineering goes. He is very respected within the community, and I loved my interview with him, and I just wanted to be able to share that with everybody out there. So I would like to thank Jim personally for taking his time out of his busy schedule to be able to sit down and talk with me about a little bit about his background, some of his experiences, and just a couple of different things that I threw in there just for fun. One point of business I'd like to do before we get started here is anybody who's accessing the show from iTunes, I would really love a review in iTunes. I'd like, if you're listening on iTunes, to rate us. If you haven't done that through iTunes, that's one thing that you might consider if you don't know that when an episode comes up. Typically, I like to do these issue them every Sunday night. Sometimes I can achieve that, but sometimes my day job gets into things. So iTunes gives you an opportunity to be able to download these on a pretty consistent basis. You don't necessarily have to go to the website to be able to listen to it, even though that's definitely an option for you. So please, anybody who's listening to us via iTunes, I would love some feedback to get that up on my profile. One of the things that I've been I would just love to see. Having said that, I think that we've prepped it enough, and so I'll get out of your way, and let's get on with this interview. We are talking here with Jim Wickert of Wickert Engineering. How you doing, Jim?
Pretty good, and you?
Excellent, good. Well, thanks for sitting down and chatting with us a little bit. I just wanted to talk to you a little bit about kind of your background and a little bit about Wickert Engineering in general. And as talking with people around the industry, I think that when you look at the people that are practicing in the Cleveland area, your name would come up again and again, I'm sure, in conversations and lists of people that are respected and kind of iconic in and around the industry. So I just wanted to have a chance to sit down and find out the real deal behind who Jim Wickert is and some of your thoughts. So I guess one of the first things that I'd start off with is when did you want to become an engineer? What was your
Well, I really just drifted in that direction, encouraged by my father. It probably developed in high school when I began to take the courses that were necessary for engineering entry. And I really didn't have any other second choice. So this was it.
So engineering, yeah. So that was what you wanted to do. You're pretty much,
Yeah, my father was a blue collar electrician, and
okay.
Among that sort of person, why engineering was the way to get out of a tough job.
Oh, sure. You use your mind instead of your back. That's always the one thing that I think about engineering.
Yeah.
And doing. So going through, you went to Case.
Yes.
Was your alma mater, Case Western Reserve University?
Case School of Applied Science at that point.
Yes. So I've come against the Case Institute versus Western Reserve kind of opinion. But now, what made you choose Case?
Well, it was local. I could ride the streetcar to college, and there were two engineering schools in Cleveland, and Case was my first choice. And I scored well on an entrance exam, so I got in. And tuition at that time was $187.50 a semester for 21 credits.
A far cry from what it is today.
Yes.
I know. So, what were some of the classes that you took at Case, being an engineer? I mean, was it wide open, or did you have to specialize right away, or how did that?
Well, you began to specialize. You had to choose a department in your sophomore year, and then in your junior year, or actually, I think in the sophomore year, you began to specialize in a particular field, and my field at the time was called heat and power, and we had a lot of how to design courses. I took heat transfer, heating, ventilating, and air conditioning, refrigeration, internal combustion engines, and instrumentation and automatic control. And internal combustion engines was particularly valuable because we studied how thermal systems adapt to varying loads, which we really didn't get in everything else. We just designed everything else for the maximum. And ICE was a good introduction to something else.
Was that one of your favorite courses there?
Well, it was an interesting course.
What would you say your favorite would be?
Oh, probably air conditioning.
So they actually
refrigeration, yeah.
They actually taught that at.
Oh yes.
That's interesting.
Bill Bryan was the lead professor in that area, and he was a fellow of ASHRAE. He edited the fundamentals volume one cycle, so he was a prominent person.
Right. So I guess was that the class that kind of made you want to go into HVAC engineering, or what? How did you come upon that?
Well, I found thermodynamics was easy for me in my sophomore year probably, and in physics, and from that point on, that was kind of the direction that I felt most comfortable in. And then HVAC gave me the opportunity to indulge the fascination with buildings that I'd had since I was a small boy. So this worked out really well for me.
So where'd you start off? Coming out of college, where'd you land your first job?
Well, my first job was at Cincinnati Air Conditioning. They were a design-build contractor and a carrier distributor in 1950. They did both air conditioning and commercial and industrial refrigeration. And an acquaintance from college, Paul Menster, had graduated a little earlier than me, and he had become the corporate liaison between carrier and carriers, distributors, and dealers in this region. He knew of the opening in Cincinnati, and he nominated me for the job, and so I was very pleased to get it.
Excellent. So what did you like about I guess what do you like about the job when you first started? I mean,
well, it was the really good thing was that I had two immediate bosses, Ivan von Walter, who was the refrigeration department head, and Bob Howard, who was the air conditioning department head. So I had two guys working with me one-on-one, and that was a great learning experience. It really was.
Excellent. So what would you see, as far as from your experiences so far? How would you recommend that students get involved in HVAC? I mean, what advice could you give them?
Well, I would advise them to try for two early jobs in succession. One would be a one-on-one apprenticeship with an experienced engineer, preferably in a design-build firm, to learn the practical basics. And then secondly, a job in a large architect and engineering firm to learn how large projects are designed and coordinated.
So when you when you get your first job, taking a look and knowing what you know now about the industry, what are some of the advantages that students can have coming into the HVAC field?
Well, I was briefly a rocket scientist. I was drafted into the Army in 1951, and I ended up being assistant cooling section chief on Werner von Braun's rocket development team at Huntsville, Alabama during 1951 and 52. And I was bored stiff. HVAC provides a lot more opportunity for the exercise of independent judgment, and you get the regular satisfaction of seeing your completed designs work.
Okay, excellent. So, what were some of your most memorable moments as a young engineer?
Oh, this was a long time ago. I can't think of anything specific particularly, but it was a growing experience.
Yeah. Okay. So, knowing what you know now, would you do anything differently about your career?
Well, over my career, I think I would have been better off if I had been more patient and not jumped around so much. But on the other hand, I wouldn't have had the great variety of different experiences that I've accumulated.
So, at what point did you say, you know what, I've had enough? I'm assuming I guess you worked at different A&E firms, and you worked for Cincinnati Air Conditioning.
Altogether, I think I've worked at 10 different organizations.
So you had a number of organizations under your belt, and what was the impetus to actually start your own shop?
Well, in 1975, I realized that moving from job to job had brought me to a dead end, and so I just decided I needed to do my own thing. And
where did you decide to set up shop?
Well, the old arcade, which is now the Regency Hyatt Hotel.
Did you start it with any sort of plan in mind? Did you just, were there any prospects that you had that were, that you had lined up to kind of make this transition a little bit easier? Did you kind of quit cold turkey and decide to?
Well, I didn't have any jobs in mind, but over the years I've made a lot of friends among architects, and they became my first clients. And I was fortunate in that when I called on them, I got work before I could really get organized to do the work. So it was a good time.
So what was your first office like? Can you describe it?
Well, it was 7 foot wide and maybe 20 feet long, and I had to buy some chairs and some steel shelving for catalogs, and I built my own drafting tables out of flush solid core doors. So that was the beginning of it.
So how long did you stay like a one-man shop?
Oh, I moved out of that office after the first year into a larger space, and I think we began to pick up some other people. My wife joined me as administrator at that point, and we began to... I don't remember who was my first employee, but... I picked up Tony Zagara fairly early, and Tony stayed with me for over 30 years. So.
Wow. I guess what were some of your favorite jobs looking back?
Well, when I was at Osborne Engineering, I designed the mechanical systems for the Robert F. Kennedy Stadium in Washington and the Nuclear Research Center campus for Union Carbide up the river from New York City. And when I was at Dalton Associates, I made 3 trips to West Africa to gather information for the design of projects.
What projects were those?
Well, the big project was the University of Liberia, which never really went ahead, but at that point in time, we were in a competition with the Russians for prestige in Africa, and Liberia was seen as under the influence of the United States, and it wasn't as well advanced as a lot of the other former colonial nations, and so we felt we had to play catch up, and so we were trying to develop this university.
So when you went over there, I guess what were some of the things that you were trying to figure out?
Well, the big thing was for the engineers on the team was to figure out how to build their particular areas of work in that economy, mm-hmm. and what the materials were, what the skills were. There were no weather statistics for the area, so I ran my sling cyclometer regularly to develop some data about what design conditions were. And there were no... the telephone system only worked when we had a sunny day. And the sun only shined in Liberia, in Monrovia, Liberia, about 3 or 4 days a year. The weather generally was just a continual drizzle. And it was almost constant at about 75 degrees and about 90% relative humidity. So I think I've lost the train of my thought there, but
so when you're designing a system like that, utilities were a big thing. I mean, obviously it had to be, a little bit.
Well, there wasn't much in the way of utilities. There was some electricity, and it worked most of the time, but not always. The problem with the telephone system was that there was no telephone directory too, and so if you were going to find out anything, why you just had to go and knock on doors, and so we developed a network and had a staff meeting every day, and everybody passed on their leads to the other people. So we went around and learned things.
Yeah. So in Cleveland, when you talk about I know that a lot of the existing companies now first started up. I guess who are some of the manufacturers reps that you had dealt with on a regular basis back when you first started out?
Well, there were firms that are no longer around, like in the air conditioning market, like Worthington and American Standard, Westinghouse, Chrysler. Mm-hmm. But I think the big difference was that the manufacturers' reps had time to teach young engineers. And I remember Walter Rogers at Thermal Products, who taught me about air distribution, and Jim Atchison from Iron Fireman, who taught me about burners. And they would come in and spend hours with young engineers, just going over questions and answering questions and lecturing. It was a great experience that I don't think exists much anymore.
So they really provided a wealth of knowledge to younger engineers.
And the economy just doesn't afford that anymore.
Right. Everything's a little bit more rushed.
Yes.
So what, I guess, as far as good stories that you may have over the years, being involved in engineering that you can possibly relate to us, and stories where you have to keep the names nameless. Any good ones?
I don't think I have any good ones at the moment.
So, I guess when you talk about practicing engineering, what do you think most of the engineers miss?
Well, they should have a better knowledge of how contractors go about doing their work. I think a lot of engineers never really understand what a contractor does and how he goes about doing it. They don't get out in the field enough. They don't actually have the experience of working in a contractor's office. The other thing is they miss good relations between architects and engineers. The two professions have two different sets of cultural values, and neither understands the other very well. And so it creates problems.
So I know that you'd mentioned your sling psychrometer, and I guess describe for people who don't know what a sling psychrometer is, what it actually is and how it works.
Well, it's two thermometers in one frame that has a sling handle on it, and the longer of the two thermometers, or the one that sticks out longer, has a cloth wick, a woven wick around it, and you dip that in water, and then you spin the thing. And the wetted bulb on the one thermometer cools by evaporation, and this produces a temperature called the wet bulb temperature, which is a function of the humidity in the air. And by taking the wet bulb temperature reading and the dry bulb reading, which is the other thermometer, you can put those on a psychrometric chart and determine all the psychrometric properties of the air.
Mm-hmm. So, and most people would relate the dry bulb temperature to what they'd see on a standard thermometer, or what they'd measure
Yes.
every day, what they'd feel. I've heard stories about the sling psychrometer in growing up in your in the industry. Can you tell me a little bit about how you use the sling psychrometer and if that was typical?
Well, of course, in Africa, I used it to develop weather data, but in Cleveland, we got some jobs where the temperature had to be held absolutely constant regardless of weather conditions. One particularly was an instrument calibration room for a major research laboratory. And so to find out what the worst possible weather conditions would be, I used to, whenever the weather got really demanding, I'd go out and run my sling psychrometer, and I plotted all those extreme conditions on a psychrometric chart. So the extreme conditions can be way above normal design and even above what is considered the normal maximum.
So you had at the time ASHRAE standards, some wet bulb, dry bulb, whatever
Yes.
whatever the standards were, but you used that in extreme
Yes.
conditions.
Mm-hmm.
Okay, yeah, I had heard stories about this was the job that was like, if you were an entry level person, you're like, okay, you go stand out and swing the sling psychrometer out in the
Everybody should do that. One of my real concerns is that all the electronic humidity sensors drift out of calibration, and they can be way out of calibration, and you may not know it. I think one of the first experiences I had in my first job at Cincinnati Air Conditioning, which did a retail business too of window units and all that sort of thing, they had a counter. And on the counter, they had humidity sensors, little round balls, about 12 of them lined up for sale. And they were all different. And they registered anywhere from 20% to 70%. So much for those primitive humidity sensors.
Oh man, yeah, and the sling psychrometers, they're still around, and they're not. I don't think they're expensive.
They're not expensive, and they do give you a pretty firm base humidity measurement.
So there's your tip for the day. Now, as far as one of some of the other stories that I've heard is your specifications. Now, I know specifications in the construction industry, obviously, typically when you have, you have your drawing set, you have your specs, that makes up kind of your construction documents. But your specifications really can vary widely from engineering house to engineering house. So, what does specifications mean to you?
Well, they're called there's a name for it that architects use, project manual or something like that. Mm-hmm. And it really provides certain guidance. But when I was at the Austin Company in 1954, I was delegated to work with an architect named Francis W. Ragg that the Austin Company had hired from the U.S. Bureau of Standards to develop a short and simple and understandable master specification. Frank was one of the founders of the Construction Specification Institute, and he was a genius at simplification. He drilled a few maxims into me. Specifications should be specific.
Go figure.
Eliminate unnecessary words. And the best model specification is a one-page cooking recipe. Say what is to be done, list the ingredients, and describe how they should be put together. Frank, frankly, would be appalled and saddened by today's 500-page products of the current master specs. Specifications are a tool to be used by contractors to build a building. They're not an end in themselves, and long, wordy specifications do not make anybody safe. Too often, master specs are not thoroughly edited to be specific, and they contain contradictory and inappropriate information. Long specifications, in my experience, are generally not read by the bidders and the contractors. They're only read carefully by attorneys and expert witnesses after problems arise. Like it or not, specifications are also frequently used by contractors to define their subcontracts. Each section should clearly define what work is included in that section and what related work is not part of that section. Misunderstandings lead to lawsuits, and I still work long and hard to make my specifications shorter and clearer.
So that was so you developed a affinity for good specifications, and that really you kept working at them constantly.
And they should be shorter and shorter and shorter. And the more words you write, the more source of confusion you can get into. And the thing that's happening today is that the master specs are so huge that they simply are not edited. Maybe a number of years ago, I was working for a major health center, and which was a tertiary care hospital and a complete range of health education facilities, medical school, and all the rest. And the facilities director was telling me a story one time about how they had an operating room and they got a specification from an architect, and he had included the baptismal font in the specs. And the facilities manager said that was the last time we used that architect.
Now, do you find that at least in my experience, and I don't know if you would agree with this, but a lot of the specifications, it's not necessarily the favorite thing for engineers to do. And typically, if you get into, say, I guess on the other side of the aisle, in the architect's sort of venue, you'll typically have slightly larger offices where somebody might be specialized to handle specifications. That doesn't typically ring true with the engineering world. Would you agree with that?
I would agree with that.
So that's kind of part of the reason it's the job nobody likes to do. But yet everybody seems to need to rely on it when troubles arise. So that was
particularly attorneys.
So I guess when did you start? Speaking of expert witnesses and attorneys, when did you start first kind of going away from doing design work to becoming an expert witness?
Well, when I was working at Osborne Engineering in the late 1950s, I got into investigating system operating problems occasionally. And then I was at the Austin Company in the 1960s. Austin is a design-build firm, and that means undivided responsibility to make things work. And they had a fellow, Paul Saylor, who had the job to resolve all the mechanical and electrical problems that arose in the field. And when Paul died suddenly about 1965, I was assigned his tasks. But I don't think that any of the problems that we had at that time ever became a lawsuit because we got them straightened out early. I was first asked to serve as an expert witness about 1976 after I'd opened my own practice.
Okay. So I guess when you talk about being an expert witness, obviously there's something that went wrong with the design. What would I would assume that it would be because of a poor design. Is this typically the case, or what do you think typically the cases are?
No, I don't think it's not usually poor design. The problems, I think, arise from poor communication, from delays, poor coordination, among other things. The sick jobs usually have multiple causes.
So you think that, if you were to give some advice to engineers to avoid litigation, avoid these kind of problems, you would say, increase your communication, use that as a focus, or what would you?
Well, my first business attorney was Bill Taft, who incidentally was also my best English teacher. But he gave good advice. He said, if all parties in an activity understand everything perfectly clearly up front, then you don't get in trouble. And this is easier said than done, but engineers should maintain good communication and strive to produce brief, clear specifications and accurate, complete drawings. Complete is perfection, and we never quite get there, but I think there's a lot of room for improvement. CAD can produce drawings that have overlapping details and imprecise identifications, and this causes misunderstandings. It's also important to stay close to the project during the construction and the early occupancy, to get to know of any problems early, and then address those problems quickly, because the longer you wait, the angrier the owner gets.
So, when you're dealing with a project, a lot of times engineers would nowadays, when you're talking about, there's less and less time because there's less and less fee spent on a job. They really try to get the design done, kind of put it out to bid, and hope everything works out okay. I think that they really need to understand and get the communication to talk with the contractor to make sure that there's good communication there, and that when the owner gets trained, they should touch base again. They just shouldn't kind of leave it at design and let it go.
Yeah, because no news is not necessarily good news, and if something festers and gets people angry, why then you're getting into trouble.
So have you in your expert witness projects that you've been dealing with, have you started to get more lead projects or green building litigation?
No, I haven't seen any yet, but I see a lot of warnings in the publications, and guaranteeing savings is a risky activity.
That's true. So what do you think are some of the weaknesses of the industry today?
Well, the pendulum has swung to the point of extreme competitive price pressure, and that extreme price pressure produces bad buildings. Strong price pressure on contractors becomes strong pressure to cut corners, and that's a hard thing to police. Inexperienced owners, especially small government entities, feel that they need to squeeze the fees of architects and engineers to serve their taxpayers. And then low-bidding contractors take advantage of the loopholes and the omissions in the drawings and specifications. I think it's clear today that more complete drawings are needed. All the contractors talk about that. They don't publicize it, but they all gripe about it. Someone, I think it was in the Cleveland Engineering Society construction conference, said that $10,000 extra spent on drawings would save $100,000 in construction costs.
Wow, that's a payback.
That's a good payback. In my opinion, I think design build offers some advantages for engineers, because contractors know the need for good drawings better than unsophisticated owners, and they're more willing to pay for them adequately and promptly too.
So do you think the industry is going more towards that design build?
Well, the industry is going towards design build. Actually, I think the state of Ohio just approved 3 projects for experimental construction procedures, varying from the format that's been law in Ohio for over 100 years, I think. So we'll see how that turns out. But small government entities are getting bad buildings today, and the system isn't working very well for owners.
Mm-hmm. So I guess what are some of are there any strengths for our industry?
Well, I think the strengths are that we're using computers. That's a big advantage from the way we used to do things. I think generally engineers entering the industry have a better basic fundamental education than they did 50 years ago. And the commissioning practice to put things in working order and train operators is a big advance. I think those are the good things.
Mm-hmm. Yeah, I've heard from engineers. Yeah, they some of them who don't really understand what commissioning is. They think of it more as insurance. But I think that in general, when you talk about getting low bid on the engineering, you get low bid on the contracting. It's frequently asked, where do you pay for the quality in the building? So just to make sure that you get the quality, that's where I've heard commissioning come into play.
that's a good point. Sal Trena, who was a consulting engineer in Cleveland for a long time, felt that very strongly that the fundamental part of commissioning originally was balancing, and he was a strong proponent of the balancing contractor being hired directly by the owner to provide some check and balance on the system. And I think many of us have had situations where we had a balance report with an airflow listed, and the thing wasn't working, and we went out and found there was no diffuser in the room. So there was a certain cynicism about the loyalty of balancers when they were hired by contractors. When I worked at Cincinnati Air Conditioning, my first job out of college, every job had 15% set aside for a line item called startup, test, and balance. And that's a necessary activity.
Yeah. Yeah, I know that even some of the clients that I work with, whether it be the Cleveland Clinic or whether it be the Ohio School Facility Commission, I know the clinic makes a policy to hire their testing and balancing agents separately. But I know that the Ohio School Facility Commission is strongly pushing the CMs and the engineers to spec out that the contract or the balancer be an independent third party because of just exactly the kind of things that you're mentioning.
It's a good move.
So, what do you think? What would you say is one quality of a great engineer?
I think it's imagination. You need to think about what could go wrong and how could it be prevented. Many years ago, an architecture professor from the University of Pennsylvania spoke at the Cleveland Engineering Society. His name was Louis Kahn, and he was a famous designer, but on this particular day he talked about professional practice. And he must have been a great teacher, but he spoke in short phrases and with pauses to let the ideas sink in between each phrase. And the thing that I remember he said that day was, the function of a professional is to ask questions. A machine can answer them. And that's about it. You really have to raise questions about what's going on, not just assume that you do it the same as the last time.
So, in your career, you've obviously, I think that we've talked before that you've had some good mentors. Can you tell me a little bit about that experience?
Well, I had some good mentors, of course, but I think the engineer that I most looked up to and respected in my career was Bob Urban. Bob was made an ASHRAE Fellow because he pioneered the use of variable airflow systems, and he designed the first building that had a successful variable volume system in downtown Cleveland, which I think is now it's a large tower. I think it's now called the International Management Group building. But the time I spent working for Bob at Byers, Urban, Klug, and Pittenger was a really unique experience, because this was the only organization in my experience in 10 different places I worked where everyone from Bob to the office boy was really truly dedicated to doing the very best work they could. I think perhaps Bob's greatest achievement was establishing that culture in his company. Another one was Ray Geiger, who was a product of a different era, and he oversaw the mechanical engineering in all the Austin Company's worldwide offices when I worked there. Ray didn't have an engineering degree, but he had a truly awesome, intuitive understanding of air conditioning theory as well as the practice and operation. And then, of course, I had a lot of other mentors. My first ones were in Cincinnati Air Conditioning, as we talked about before. And then when I was at the Rocket Development Center in Huntsville, Alabama, Johannes Georg Paul taught me German thoroughness and documentation. At Osborne Engineering, there was Homer Borton and Elmer Junkie. And late in my career, I had regular lunches with David Lewin, the geotechnical engineer, and he gave me a lot of guidance in professional practice.
So how would you, I mean, I wouldn't say that I've had too many mentors in my career, and obviously you've listed a number of them that have been able to help you and assist you along the way. Is this something that is becoming more and more infrequent, or I guess how could people kind of try to find a mentor?
Well, I think there's more recognition of the value of mentors today, and I think most older people in any field enjoy training young people. I think there's more of it developing. It's not always easy to find, but I think it's becoming more recognized as the proper way to go.
Okay. Now for some more lighthearted questions. What do you think? What has been your favorite, whether it be device, environment, or equipment, or technology that you've seen?
Well, I think the thing that's really a major step forward is direct digital controls, DDC electronic systems. They're a great advance over the old pneumatic and low voltage electric controls that we had, which I remember one time Bob Urban talking about a job that we had designed with pneumatic controls, and it had a control panel that was maybe 20 feet long and 6 feet tall and covered with gauges. And Bob, with his mournful expression, said, "And they're all wrong." Well, we're so much more accurate with direct digital controls. It's a great step forward.
So, and I would agree with that. I think that even though a lot of what we find is the lack of thoroughness typically on a job, when we commission it, we find that they do an excellent job at 98% of what they do, but there's this 2% that's really gums up the works when it comes to trying to commission a system and just different settings that aren't applied. So I guess the moral is that DDC offers you a great range of programmability, understandability. You have to be careful about when you program it, just to be thorough.
And get the right settings.
Right, absolutely. So, but if there's something wrong, it's easier to change than if you had a 20-foot by 6-foot panel of pneumatics that didn't quite work. I'm assuming that troubleshooting that would be quite the labor-intensive exercise.
Well, one of the problems with pneumatic controls was that they would act too rapidly sometimes. I remember one time I found a job, went out on a job where we had about a 1,300-ton centrifugal chiller, and the motor load was swinging wildly from. We were operating on cold water, cold condenser water. It was cold weather, and the motor load was swinging all the way from about 200 or 300 horsepower to 1,300, back and forth, really quickly. And the only way we could finally get it to stabilize it was to take a pair of pliers on a pneumatic sensing line and squeeze it. And this provided enough restriction to slow down the sensing and calm the system down.
A mechanical PID loop, I guess.
Well, we didn't have PID loops at that time. It was a real problem. There was another one I was trying to think of that... a chronic problem with pneumatic systems was when you had a 100% outside air system and you had a shutdown in freezing weather, and you had to get that system back on the line without being shut down by your freeze stat. And pneumatic systems just didn't have the ability to come back online very well. It was very tricky. With a DDC system, you can program the thing to very gradually add more outside air and allow the controls to adapt to it as you bring in more and more outside air. And so it makes it possible to get online now without nuisance shutdowns with pneumatics. Why, if you're trying to do that, you really had a problem.
So what are some of the things that you've been frustrated most with or disappointed with, that you thought it was one thing and it turned out to be something completely different, some equipment that you've used?
Well, one thing that was very popular for a brief period, I think this was back in the, maybe about the late 60s or so, was a 3-pipe hydronic system. It had a hot supply and a cold supply and a common return, and of course you ended up with the heating and the chilled water fighting each other in mild weather, so it wasn't a very good system, but it took a few years for people to figure that out. In the meantime, I think somebody had a patent on it and was trying to collect royalties from all the contractors who used it. Another thing was a multi-zone rooftop HVAC unit. They were used a lot in schools, and I remember working on one large school job where we had a lot of them, and a college friend of mine was a manufacturer's rep who got the order for some, and he said he went out one warm summer day and he found the furnace going full blast on all these units. And he said, I would have gone broke if the factory hadn't backed me up and got those things working somehow. But there were major, major problems with those things. And it was basically the furnace was an on-off operation, and it didn't work very well with the multi-zone unit.
Oh, jeez. So, what out of the buildings that you've seen done, what has been your favorite building, and kind of why?
Well, it's usually the one that I'm working on at the moment. But one recent one that was fascinating was restoring the old mechanically induced vacuum condensate return steam heating system in the Alcazar Hotel. Bringing that thing back to working order was a lot of fun. Because people had tinkered with it over the years, and the usual mechanics approach was that, well, I don't really know, but let's try this. And so over the years, they'd ended up with some problems, and they weren't able to heat parts of the building. And most people in our industry really don't have any experience. The people that are left around don't have any experience with these systems anymore. And but they were state-of-the-art around 1920. I was fortunate to have some books that were written by a fellow named Dan Holohan, who is based on Long Island and who has had a lot of experience with those systems in New York City. And so his books gave me a lot of guidance, and they're a thing I would recommend anybody doing that sort of thing.
So if you were trapped on a desert island and you had to do engineering, you had to pick one of your favorite things that you had to have, what would it have to be?
A way out.
So, okay, fair enough. IP or metric?
Well, I think it'll come someday, but not soon, and I think incrementally. We're getting some dimensions now that are, I think I can think of one pump that has metric dimensions, which are really the metric equivalent of the inches that we normally size pipe for.
Huh.
We're drifting in that direction, but it's not going to happen very soon. We have too much invested in our present system.
Now, what about, what's your favorite temperature?
Oh, I would say about 68 degrees, which is 20 degrees Celsius.
And did you have any favorite sports?
Well, I played sandlot football when I was in high school, but when I went to Case, they had a good system, and no one was ever cut from a varsity team. And everybody was expected to go out. So I became seventh string in the wrestling, in my weight class in the wrestling team. And the heavyweight was Bill Kerslake. He was the first string heavyweight, and he weighed 265 pounds, which was a giant for his day. The biggest football tackles were about 220 pounds then.
Wow.
And I remember working out with him, and I almost had him pinned one day, and then he just stood up. Bill went on to captain the U.S. Olympic wrestling team twice.
Oh, yeah? Wow.
Yeah.
Excellent. So what was the I know that there's a big rivalry between Case and Western Reserve as far as football goes. But
well, that ended with the two schools merged. But yeah, it had been a rivalry, and it was the Thanksgiving Day game for probably 40 or 50 years. And I think it was 1948 that Case beat Reserve for the first time in, I think it was 27 years. And, that was quite a celebration.
all right, and what is your favorite type of pie? And leaving it with that.
Oh, I think mincemeat, and you can no longer find it.
All right. Well, I appreciate you taking your time to sit down and talk with us. If anybody wants to get in touch with you, what's the best way to do that?
Well, my website is www.wickertengineering.com. My email is WICKENG, the contraction of Wickert Engineering, at earthlink.net. My telephone is area code 216-696-5729. And I'm usually here 5 days each week at room 668 in the Hanna Building at 1422 Euclid Avenue in Cleveland.
All right. Well, I'll if you didn't catch that, I'm going to post that on the show notes. So we'll be all set. And again, thank you for your time, Jim.
Well, thank you.
All right.
It's been a pleasure.
All right, we're back. That was a great interview, and again, I'd like to thank Jim Wickert for his time. I'm going to put his contact information, and if you want to get a hold of Jim, I'll put that all up in the show notes on the website. Again, this is kind of one of the types of interviews. They all are not going to be informative in the sense that about a new product that's energy efficient or something that's really great or some different way to apply things. Sometimes, I really think this is valuable information that I want to be able to get out to the world, to be able to listen to building professionals, whether it be an engineer, whether it be somebody, a contractor or a building maintenance person. If you have anybody that you know of that you'd really like to hear from, or that you've talked to them a number of times, or they're a mentor to you, and they really think that what they have to say is really something that you'd love to share with the rest of us, please drop me a line at buildingx.co or email me at matt@buildingx.co. You can also find me on Twitter at buildingx. And that's pretty much it. Just let me know. We really appreciate those kind of people, and we want to be able to share their experiences with the rest of the world. So, again, I appreciate everybody listening. I think it's really, really great that we're building up to this. And if you have any other things that you want to get a hold of me at, I think there was I did mention, I'll put Jim's contact information on the show notes at buildingx.co, and that's pretty much it. So until next time, know what you build and share what you know.